Hey, I'm over here. All right, today we're going to look at another way to represent data. Yesterday we looked at frequency tables. In this lesson, we're going to look at a dot plot, and then later we're going to look at a pictograph. Right now, let's do dot plots, okay? Dot plots are a lot like a graph. It's just instead of like a bar graph or pictures, it's dots. And so a dot plot uses dots, hello, that's easy, to record each piece of data above a number line. Okay, it helps you see groups in data. It helps you compare. So here's the example they did. Some students took a survey of the number of letters in their first names, and they recorded their data in a dot plot. So you see here we have a number line. Each dot represents one student, and this number line is how many letters are in their first name. So the main question they want to know first is how many students answered the survey. Let's see. Do you think that answer is 8 because that's the top number? No, because look, each dot represents one student. So we have to look at how many dots there are. These dots are answers. These dots are students, okay? So let's see. We've got 6 in this line, plus 5 is 11, plus 4 is 15, 16, 17, 18, 19, 20. Okay, that's how I counted it up. I like to go with the largest numbers first and then add on the small ones. You might like to go in order of adding, and you might just want to use your finger and touch and point. Any of those is okay with me, as long as you get to the correct answer. So 20 students answered the survey. We know that because there are 20 different dots. The least number of letters, what they're asking here is, what was the smallest number available? Okay, they're not asking the least number of students. They're asking the least number of letters. So that answer is going to be 3 because the number line shows us the least and the greatest number of letters. That means that no student had 2 letters or 1 letter in their first name. Okay, so the answer to the least number of letters is 3. The largest number of letters, the greatest, is going to be 8 because that's the largest one represented here. Nobody in the class had 9 or more letters. 8 was the largest. You see that? And so the question here is, how many letters do the most students have? Okay, so which number of letters down here has the most dots? That's easy, right? 5. You can tell just by looking. You don't even have to count because the dots go up higher here for 5. Good. All right. Moving on. Okay, so they are gonna have us do a little tally here, and let's see. I thought I had some dice right here. I do. Hang on 5 seconds. I'll be there in a minute. Here I come. Okay, I actually had double dice. Have y'all ever seen double dice? They're kind of my favorite. I'm sorry, where's the camera? Here's the camera. It's a big dice with a tiny baby dice on the inside, but I'm not going to worry about the baby dice. I'm just going to look at the big number because that's what it's asking. Okay, so each member of your group should toss a number cube 1 time. Combine your data with the other group's data. Oh my goodness, that's a lot. So we're actually not going to do this one because that's putting all of the groups together, and that is something we would do as a full class, and that is hard to do. So you guys, we're gonna move on from that, and here's what we'll do instead. I'm gonna toss this one, and this is gonna be the number toss. This is our first try, so ignore sort of the instructions. You can't see. I'm covering it up with my hand. Ignore the instructions, and I'm gonna fill out the tally chart. So let's see. This is my first try, and I got a 6. Okay, so let's see. Let me draw. Sure, purple works. So for the first try, I got a 6. 3. Oh, you know what? Hang on. Bug it up. I'm not going to do that. That doesn't make sense. So I don't really like the way this experiment is set up. So I'm going to do it my own way. Are you ready? So the number tossed is the options. Okay, so we have on a dice, we have a 1, 2, 3, 4. Sorry, I'm drawing with my computer mouse. It's a little tricky. 5 and 6. So those are all the choices. You cannot roll a 0 or a 7 on a dice. All right. And so I'm going to do it. I'm going to do this 10 different times, and we'll see how many we get. So there's a 2. There's 1 tally. There's a 4. There's another 4. There's a 3. How many is that so far? That's 4. There's a 6. There's a 2. Sorry you can't see it. There's a 1. Okay, 1, 2, 3, 4, 5, 6, 7. I need to do 3 more times. There's another 1. 2 more times. There's a 5. Oh, good. I was worried about that 5. I thought he was going to be lonely. And another 1. Okay. So that gives us some information. That gives us some data. Now we're going to do dots. And I'm going to make it a little bit bigger. Oh, that's a little too big. I don't want to get too excited there. That's good. Okay, so I'm going to do purple dots to represent our tallies. And so our possibilities are 1, 2, 3, 4, 5, 6, just like up here. So all we have to do is, instead of tallies, we do dots. Okay, so for the 1, there were 3 tallies. So we've got 1. Oh, I thought they were going to be purple. That's okay. 2, 3. Okay, for the 2, how many dots are we going to do? Well, that's so lucky. 2 is 2. All right, and for the 3, just 1. For the 4, 2. For the 5, 1. And for the 6, 1. All right, so what do the numbers tell us? Which one was rolled the most times? 1 was rolled the most. What was rolled the least? 3 and 5, right? They were, oh, and 6. 3, 5, and 6 were all equally the least. And 2s and 4s were more likely than 3, 4, 3, 5, and 6. Okay, so that's what the data tells us there. Sometimes I have to adjust the experiment to the way I like it, and that's all right. Okay, so they did a survey over here. So what we're doing now is we're looking at a frequency chart, like what we looked at yesterday. This is one of the ones that has the category, the tallies, and the frequency numbers. So they did all of that work for us. Now we're going to put it on a dot plot, okay? So we're just going to take this information and put it on a dot. So, oh, sorry, let's get to the pen there. That's a good size. Okay, so they're asking the number of siblings for each student, okay? How many students had 0 siblings? 3. So we're going to put 3 dots. It's important when you're doing a dot plot to keep your spacing the same. I'll show you why. Okay, so for the number of students that had 1 sibling only, that went up to 10. So I'm going to try to line them up, because that way when you're looking at the data, if I spaced my 3 out like this, do you see how that would look like it was more than it actually is? So you want to kind of keep your spacing equal as best you can. It's kind of hard to do on a laptop. 1, 2, 3, 4, 5, 6. I'm going to go over the title here. 7, 8, 9, 10. Okay. How many students had 2 siblings? That is 6. 1, 2, 3, 4, 5. Oops. 6. Sorry, I made that one too high. Okay. 3 students had 3 siblings. 1 student had 4 siblings. 0 students had 5, so we don't put any dots here. None of them had that. 1 student had 6 siblings. Wow. And 0 students had the others, 7, 8, and 9. Okay, so here's our results. What was the most? 1, right? Look how tall those dots go. Most of the kids had 1 sibling. A good number of them also had 2. A few were only children, a few had 3, and only a couple had 4 or 6. Okay, so that's how that goes. All right, now they're going to see, and excuse me, sorry, see if I can get, sometimes that makes it show up here. That's the problem. Okay, so the results are in the dot plot. Now we're doing it backwards. We're going to take it, instead of taking it from a frequency table to a dot plot, we're going to go from a dot plot to a frequency table. You need to be able to go both ways, okay? So, would you look at that? They like to talk about Jose's home runs by month. This is the same data we had the other day. I'm going to do a text. Okay, so this is going to be the months. So we have April, May, June, July, August, and September. Something I haven't done yet that I need to do is our categories. So up here, what do you think I'm going to write? Months, right? And then over here, it's going to be the same thing we did yesterday. Number of home runs. And actually, they made home runs 2 words, so I'm going to do that to make it correct. Okay? All right. Now, here's the trick. So sometimes in dot plots, if they have larger numbers, they don't want to draw a million dots. And so they will have 1 dot. Look at this key right here. 1 dot equals 2 home runs. So this reminds me of our math paper we did maybe a couple of weeks ago where 1 shoe on the pictograph was counted for 1 pair, and so 1 picture of a shoe really meant 2 shoes, and that tripped a bunch of us up. That was way tricky. Okay, so they did the same thing here. So now we're going to have to use our critical thinking skills to figure this out. So each dot represents 2 home runs, so we need to count this by 2s, right? 2, 4, 6, 8, 10, 12, 14. So April had 14. Oops, not 114. 14 runs. How many did May have? Did you guys work it out yet? 6, right? Because there's 3 dots. 3 times 2 is 6, all right? All we're doing is doubling it. June had 4 dots, so that gives us 8 home runs because each dot counts for 2. I'm going to try to line these up better. Okay, July had 3 dots, so that's going to be the same 6 as May. August had 4 dots, which means 8 home runs, because each dot counts for 2. And September had 1, 2, 3, 4, 5 dots, which counts for 10 home runs. Okay, so this is what your data would look like in a frequency table that you took from a dot plot with a tricky key. Ooh, they tried to trip us up, but we're too smart for them. They can't trick us. All right. So now they've given us some information up here that we have to put in a dot plot. And I like how instead of dots, they used X's. And that's fine. X's, dots, it all works out the same. So let's see. She realized she forgot to represent the students with 3 siblings. She totally forgot to include that data on her chart. So if there were this is a big problem solver. This is like a multi-step. If there are a total of 24 students in Mrs. Curry's class, complete the dot plot to represent the students with 3 siblings. So what they're saying here is there are 24 students in her class, but some of them didn't answer, or she forgot to include their answers. So first thing we need to figure out is how many did answer. So I'm going to go with the largest number first because that's easiest to count for me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, so I'm just going to write over here, oops, sorry, to keep, goodness, it's giving me all the options that I don't want here. Text box. So 21 students are represented here on the dot plot, but they told us that 24 students are in the class. So what are we trying to do here? What do we need to do? Do we need to add those numbers together, or do we need to subtract them? We need to subtract them, right? And so 24 minus 21 is just 3, right? So that tells us that we need, oh goodness, it's drawing without permission. That tells us that we need to do 3 X's on 3. Do you see how we got that? Because they told us that all of the ones that didn't answer were the ones that had 3 siblings. They gave us that information up here. And so that's how we finished the chart. Okay. All right, and we have 20 seconds. Let's see if we can do it. Which one matches? All right, 0, 0. Well, that's not right, so it can't be that. 0 pets, 3 students. 1, 5, 2, 5, 3, 4, 1, and 2. I think it's this one, but let's check. Oh my goodness, look, they have the numbers all out of order. I can already tell you that's wrong. They would